Welcome to Spring LIB.
Okay, so our first radical looks like this, and we need to draw all resonance structures for it. So I'll draw the mechanism for the first resonance structure, just to show how it is this happens, and then from there we'll see the rule and be able to just draw the rest of the resonance structures for the other structures. So the idea is that a single electron comes together, the single electron from the lone radical comes together with a single electron from the double bond to form a new bond, and the other single electron from the double bond moves over to one of the atoms that it is currently connected to. And this gives you a single electron at this carbon and a new double bond there. So basically what happens is the double bond moves over by one, right? And the radical kind of hops over two atoms to where the double bond used to connect. Okay, so for this structure, we can move the radical over by two. Right, that's not actually an electron pushing arrow. And the double bond will move over, it'll sort of swing down by one. That's the pattern. Like so. And the same thing can happen with this double bond now. Those are the resonance structures for that one. Okay, so sorry, I'll label these. That's A, that's B, here's C. What's kind of interesting is that C is exactly the same as B. It's just starting from the other side, but notice that the central resonance structure is in fact the same. Okay, and then it moves over to give us the same structure as the first one from B. Okay, now we'll look at D. Now this will be a little different. It can, oh no, this is pretty much the same, sorry. We can choose to either hop it to the right or hop it to the left, but they'll circle back around, so it won't make a big difference. Let's start by hopping it to the left, right? So we go 2 atoms over with our radical electron and then swing the double bond down. Okay, and one more time, now using this double bond. Like so. All right, finally E is going to be the longest of these. Okay, there's only one direction that can move. It's got to move down to the left, and then the double bond will swing up. Like so. Now it can move all the way over here, 1, 2, and this double bond will swing over. Now we can keep it moving. We'll move up and to the left. Try to draw that as a double bond. Do a little better. Okay, but this double bond will swing down. Radical will move. And finally, this double bond will move, and the radical will swing over. There is in fact another resonance structure we can draw, because now this radical is neighboring this bond, which means this radical can move 1, 2 down here, and the double bond will move into that central position. And the final move would bring us back to where we started, but slightly different. So I guess that's technically another resonance structure as well. This radical can move 1, 2 up here, and then this double bond can move here. Like so. This is very similar to the original structure. I'll draw the original structure again. We'll notice that the only difference is how we've drawn the double bonds in the left half of the ring. But it is technically a different resonance structure. Yeah, so these would be 1, 2, 3, 4, 5, 6, 7, all 7 of them.